So in this video, we're going to start our discussion of the difference quotient. The difference quotient you've probably seen before. It comes from the equation for the slope of a line. So if you have a linear function y equals mx plus b, the slope is m, and maybe you remember the formula for the slope. If you're given 2 points, x1, y1, and x2, y2 on the line, then you can determine the slope as long as the 2 points aren't the same. You can determine the slope using the formula m equals, in this formula, right? M equals y2 minus y1 over x2 minus x1. This is the infamous rise over run thing, right? x2 minus y2 minus y1 over x2 minus x1. Remember, the y's go on top, the x's go on bottom. So this equation for the slope is called the difference quotient. That's because it's a quotient of differences. So that's what the difference quotient is the equation for a slope of a line. Well, it's the right-hand side of the equation for the slope of a line. The left hand just being m. In function notation, we would write y1 equals f of x1 and y2 equals f of x2. And just substitute those in my difference quotient, and I get m equals f of x2 minus f of x1 over x2 minus x1. Now, this is used a lot in advanced calculus, sometimes in regular calculus. But in regular calculus, most often we're computing the difference quotient for some given function. And we want to be able to compute things easier, and it's difficult to divide by a binomial. So we would prefer to divide by a monomial. So we do this little trick where we just make up a letter, which is going to be h, and we set it equal to x2 minus x1. And that right there. And that makes this an h, which is a monomial. So then we're just dividing by monomial. Okay, so let me write that out. So this is to make computations easier. Set x2 minus x sub 1 equal to h. Okay, now this makes the denominator a single term, h. But it also adds an extra letter. So we had x sub 2, x sub 1, and now we have x sub h. So now we have 3 letters instead of just 2. We don't like that, so we want to get rid of either the x1 or the x2. We're going to get rid of the x2, and the way we do that is just take this right here, solve for x sub 2, and plug the result in here for x sub 2. So x sub 2 equals x sub 1 plus h. And then if you plug in that x plus 1 plus h for x sub 2 as the input of the function f, the blue one, you get f of x1 plus h minus f of x1 over h. And then what we usually do, right, so I just made those 2 substitutions. Now I don't have an x2 left, so I only have the 2 inputs, h and x1. Now what you do usually is, we don't usually write the sub 1. We don't have a sub 2 anymore to compare it with, so we don't really need the sub 1. Sometimes people do, or sometimes they'll write x sub 0. But most of the time we'll either we'll change the x sub 1 into just x, or we'll change it into something like a. Okay, so that looks like this. So the slope is f of x plus h minus f of x over h. Or if I use an a instead, f of a plus h minus f of a over h. Okay, that's just substituting a for x in the previous one. They both mean the same thing, as far as we're concerned. Okay, so that's a definition. So you should know this formula here, this one. Oops, can't get my pointer. There we go. You should know this formula. And just know that you could put a different letter there for x if you wanted to.